All right. Let's see here. Doing a fast video or a quick video on this unit. This unit is a Motorola unit. It was originally donated to us from a public service or a public safety agency. It's rated at 110 watts. It's in the PEG radio. It's in the PEG band, 42 to 50, and it's been modified from a remote base to a combo unit, a node and link repeater for a Category 3 system that we have here on the RIPEG network in Rhode Island. If I tip this down, I'll try to show you what's going on with this. Okay, so these two radios and this controller make up the node. So this is essentially a node kit. But because we're combining a node with a repeater, there's also a repeater here. That's the repeater controller and the repeater transceiver. Okay? Because of the proximity between the link radio of the node and the repeater, there's no need to put an antenna on this. Normally this link radio would have a Yagi antenna and it would be pointed at the repeater, but since the repeater and the node in this case are in the same cabinet, there's no need to do that. So there is a dummy load attached directly to the link radio because, like I said, it's only transmitting right to here. Now, this radio would have its own omnidirectional vertical antenna, something of high gain, between 3 and 7 dB would be nice. A standard collinear base station type of antenna. And the low band radio of the node would also be using an omnidirectional antenna, maybe a half-wave dipole, or a quarter wave ground plane or something like that. Okay, these are the new controllers. The what did I call them? The MSX controllers, 100s. Even though they are in the old housings, the red and silver housings, they are actually the new controller. That controller also is going to be available, and I like these cases better, so I think this will be the standard case with the mounting tabs on it. This particular one is a Wi-Fi version, but it should come in a non-Wi-Fi version as well. Okay, let's go over the path, the signal path, and how the signal functions through the node. And also how it works its way over to the repeater. Okay, this node is actually going to be installed next week, and it's going to be the primary node of Zone 3. So this is essentially Zone 3, which of course is Channel 3, right? We set it to Channel 3. So when I transmit on a field radio, the low band radio of the node receives it, and it gets sensed by the controller. The controller does two things at that point. It tells this radio to go from its receive state, as it's receiving me, immediately over to its transmit state, transmit a Q tone so that everybody in the zone knows that somebody just pressed the PTT button on a radio. But at the same time it's doing that, it's also transmitting on the link radio, which is basically being received by the repeater radio, and the controller is sensing that and sending out a separate frequency Q tone on every other zone. Alright? And then what happens is when I let go of the PTT button on your radio, naturally the controller will tell the repeater radio to transmit, and it's going to go in reverse. Now it's going to be received by the link radio of the node and rebroadcasted back out onto the low band radio of that node. If this were a standard node, we wouldn't have a repeater in here. The repeater would be at a separate site all by itself, and all the nodes would just be this configuration here with a Yagi antenna connected to the link radio and pointing over to the repeater. But this circumstance, some circumstances, if you have permit this to work, or permit this package to be used instead. The situation that I have here in the state is that I have a site in the middle of the state, in the middle of our coverage area. So it's also very high in elevation, so it functions very well as the link repeater. But that same location would also be really well served by a node at the same location for local coverage. So that's why I combined the two into one. It's a little bit more complicated to get everything situated, but once it's set up, it's a no-brainer. Okay, so let's do some tests. I transmit on here again, gets received by the low band node radio, sends out the Q tone. At the same time the Q tone's going out local, it's transmitting on the link radio to the repeater. The repeater is processing in that, and then when I let go, it sends it all back through the node. Now that's not just this node, every node. When this repeater radio transmits, it gets received by all the link radios on every node that you have in your system. Again, this is a category 3 system, so that's a multi-zone system. Okay? So on a multi-zone system, on a category 3 system, the repeater resides in the link band, not in low band. Alright, so whatever the link band, in this case it's UHF, but whatever the link band is, that's the frequency range that the repeater radio resides in. Okay, so let's transmit. Now in the background, I got a couple of radios over here. You see that radio right there? That's what you're hearing the Q tone from. So when I transmit, you're going to hear the high-pitched Q tone on this radio, because this radio and this radio reside in zone 3. So they're in the same zone. And because they're in the same zone, you hear the high-pitched Q tone. Hear that? One more time. 5, 4, 3, 2, 1.
5, 4, 3, 2, 1.
Now, back here, I'm going to zoom in a little bit on this so you get to see what's going on. Again, these are the new controllers. Okay, so when I transmit here, 1S1 radio check, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5.
1S1 radio check, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5.
I'm going to zoom in extra tight right now on the controller. Okay, again, this is the node controller. This is the repeater controller. I'm going to transmit again on this on the low band portable. Check 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Check 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Okay. This is transmitting from this radio and going out on the node. Again, it's being received by all nodes in the system, not just this one, but in this case, this is a small test, and I'm just showing you it on the node that's actually in the same cabinet. Now, I'm going to back up a little bit. Again, I'm going to show you this radio. Again, this radio and this portable are in the same zone. Because they're in the same zone, you're going to hear the higher pitched Q tone. Again, when I transmit, listen. Check 1, 2, 3, 4, 5.
Check 1, 2, 3, 4, 5.
Okay? That basically means that if this was you and this was me, and I transmitted and you and I naturally are in the same zone, you know the moment I transmit that the person that's transmitting is in your zone because you're hearing the high-pitched tone. Okay, now this radio here is actually programmed for zone 1. So this is zone 3, this is in zone 1. Now watch what happens when I transmit on this radio being in zone 1, meaning not in the same zone as this radio. You hear the low pitch tone?
You hear the low pitch tone?
Again. So in zone traffic, no matter where you are, you'll always hear a high-pitched tone for in-zone traffic. If you hear a low-pitched tone, that means the person that's talking is not in the same zone as you. The reason why that might be handy is because if you wanted to talk to somebody and take them over to a TAC channel, one of the simplex channels that you might have set up, that's the way you would know. If you hear a low-pitched tone, you know they're not in your zone, so the chances of you being able to go direct with them on simplex is probably not going to happen. So that's out of zone, this is in zone. Okay? You can hear there's a little bit. If I turn up the volume of both of these radios, you're going to hear a little bit of a almost a flanging effect. That flanging effect is the controllers over here processing the information, and it is just like a 25 millisecond delay as I talk, and you can hear the flange on both radios. Check 1 2 5 4 3 2 1 1 2 3 4 5. Listen.
Check 1 2 5 4 3 2 1 1 2 3 4 5.
That's because the repeater radio is receiving it at a different. The repeater controller, rather, is sending the data out, and it's being received by the other controller, the node controller, and there's a little bit of a delay between that process. It's an electronic delay. All right, so that's how that works. Is high-pitched Q tones are coming from the same zone. Low-pitched Q tones are coming from outside the zone. Again, if I key up on an outside zone, low-pitched. If I key up on a in-zone radio, on the same zone as this radio, high-pitched tone. Okay? Now, the other option, let me take you over here. The other option, instead of a 60-watt max-track radio, you also could use a Maritrack radio. These all have to be modified. They will not work off the shelf for node use. These are typically used in mobile applications, but they are a monster. It's rated at 110 watts mobile. The transmitter section and amplifier back here, and the receiver is here. They have a programming port right here that also can be used as an interface port. In fact, you have no choice because this massive connector does not actually have any extra pins in it that I would need to make this into a node. So what we do is we modify the cover, and we also modify the electronics inside and add the appropriate signal wires to this plug that is not there right now. And then we simply plug the controller directly into here, and what that will do is make this become either a repeater radio on a category 1 or 2, or a node radio on a category 3. So that's an option too. This also can be used as a base station radio with no modification. They're fairly inexpensive now. My understanding is they retailed for about $2,300 when they were new in the early 90s. This is the control head for it. This is what they call the advanced control head. With the microphone, external speaker, they draw about 18 to 20 amps on transmit. They are capable of actually transmitting 170 watts or 175, but they're not rated that high, and I would never run them anywhere near that high. So anyway, that's an option. Now over here, let's see, I got a few odds and ends over here. Peter's max tracks and radiuses, a base station consolette, a bunch of Vertex VXRs. I'm sorry, VX 4000s and 5500s. The 2-channel max tracks that go through the modification process to use as a node radio, and a bunch of UHF link radios, the CDM 750s. I have a lot of stuff out on loan and testing right now, so I have very little right now in terms of portables. But anyway, these are the P200 low-band portables. Over here, that's a VHF one, VHF VX4000. I had this is for the console system in the vehicle. These were made. I made these special for each brand radio, and they're custom made for each one. This is a blank, uncut. Let me show you how this works. So this is a standard blank for those size consoles. Now that console is, the reason why I made that console is, 1, I needed it, but 2, I also needed it to see what would work well for a little base station and repeater and node console. So what I'd like to do is, you see these are commercially made base consoles. The problem is they're way too expensive. They use all expensive components, including the power supply, and I was trying to get away from that. So what I want to do is I want to build something like that, a little bit taller. But I want to have USB ports, and I want to have all the switching capabilities with a switching power supply and everything, and a modular type of connection so that you can put any brand radio in there and it looks just as nice, rather than trying to build the console to fit one particular brand. So this is the way I did it. This is a piece of 3/16 inch masonite. It's 3 inches by 9 1/4. Now all I need to do to make this into a bezel for a particular brand radio, like these are for Max Tracks. I think this is CDM and the Vertex, is I just simply take a blank and I go over here to this template. This is a jig, and say I wanted to make a new template for, or a new bezel plate for a Max Track radius or something. I simply slide it in to the template, lock it into place, and I use a router and I blow around this thing with the router. It has a the router actually is equipped with a bit, a special flush cutting bit, and a collar, a guide collar that rides on this template. And once it's done, I simply eject it. I eject it, and then it's made and ready to go, and all I have to do is fasten the bracket system on it with the rivets. It works very well. So anyway, that becomes the standard of the system, and now I can cost effectively make bezel plates for specific radios and have them fit into a standard size console, and that console can be used for personal base stations, repeaters, and node stations, and everything will be self-contained. Anyway, okay, I think that's pretty good. I just wanted to show you the basic operation of the node, and in this case, this is a node combo. Now, I do have a video coming out that gives great detail in the modification process of this. This has also been modified to have a battery backup system. Down here is a transfer switch that I had made. That's automatic transfer, that when the AC fails, this will switch over to battery power. The battery terminals are right here. This is a 30 amp rated battery terminal. These two wires get connected to the battery bank that would be over here next to this. I'm going to show you the installation of this. It's actually going to go about 20-25 feet off the ground inside of a utility building at a high location in the state, and I'll kind of go over that later on. So anyway, I hope you enjoyed that video. This is just a casual video on the combination node and repeater station that's going to go up in the center of the RIPEG network in Rhode Island.